Welcome everyone to Leveraging User Intents for Personalization with Rishabh. Rishabh is the Director of Machine Learning at ShareChat and is the instructor for Corize's Personalized Recommendations at Scale course, which is starting next Monday. And I will leave it for Rishabh to take away.
Okay, perfect. Welcome everyone. Thanks, Barbara, for the introduction, and sorry about the couple of minutes delay before we get started. So today we're going to talk about leveraging user intent for personalization, and we're going to spend like close to 30 to 40 minutes. I want to reserve time for questions, and I also want to correct my email. There's a dot in here. Perfect, yes. So my name is Rishabh. I am currently based in London. I work at ShareChat, based in London as a director of machine learning. And we are going to spend time talking today about mapping intents, intent prediction, leveraging intents. So everything around intent and how do we use it for personalization. So just a quick background, I'm currently at ShareChat. Up until last year, I was at Spotify. Before that, I did a few internships at Microsoft Research, did my undergrad from BITS in India, and then PhD from UCL. In terms of topics, generally interested in anything related to machine learning for marketplace, but also like personalization. And more recently, I started to delve into a bit more of creator ecosystem as well. So the focus of today's talk is going to be on how do we leverage user intent for personalization in different industrial systems. And if you look at industrial systems, then one of the key parts over here is that they're pretty interactive. So we have a bunch of interactions. Just give me a second. Yeah, okay. Yeah, so we have a bunch of interactions which are back and forth between the user and the app. So if I look at the interactive systems itself, then often when user has an information need or task, they go to any of these platforms, either to find information or to buy some product or watch some movies, stream some music, look at some entertaining content, find some trending content. So there's a need which facilitates this access to one of the apps. And accordingly, what the system does is it tries to offer you a personalized offering. So this is where like the system tries to understand what your need is, what your intent is, tries to develop these representations about you, and then try to use them to personalize the recommendations better. And once you do that, then you're seeing a bunch of recommendations, you're acting with these items on the app, and then you're leaving these fine-grained interaction signals, like your click, mouse gestures, purchase history, like your skip behavior, clicking behavior, scrolling behavior, all of those. And based on that, the system is able to then try to identify and understand whether you are a happy user or not. So whether you were okay with our recommendations or were you not okay? Were you happy with the recommendations, were you not? So this is the overall high-level view of how interactive systems actually work. And in here, right, if we try to look this from the lens of intents, then what are the problems which arise? How do we solve these problems? How do we leverage intents for personalization in interactive systems wherein the user and the system are doing some back and forth between different sessions and different types of engagements, essentially. So what we want to do today is we want to start by looking at this entire process through the lens of intents. And then we're going to start looking at how do we map the intent space, because again, like the intents may or may not be always obvious. And then once we have the intent space, then how do we predict intent? And once you've predicted intent, then how can we start leveraging intents for personalization? And then we're going to close with a quick summary and some discussion. So I do want to, again, each of these are worth going into very details of a talk in itself, but then I'm going to give you a broad view of what happens in search, what happens in recommendations, and then hopefully we can use the last 15 minutes for a bit more back and forth discussion. Perfect. So for the intro, let's start looking at user engagements on these apps through the lens of intents. So on the leftmost extreme, we're going to look at search. So web search, you go to Bing or Google or ChatGPT, like whatever your favorite search app is, you're going to type in a query. The moment you type in a query, you're explicitly telling us what your intent is. That, hey, I want to look at the results of Wimbledon or Australian Open 2023. And then the search system will try to find that for you. And this is not just search, this is also like your digital assistants like Cortana, Google Home, or Siri. You're going to type in a query or voice over a query, and then we're going to understand that, okay, this is your intent. I'm going to try to surface recommendations accordingly. But then if you look at the other extreme, then you go to the homepage of some of these apps. So if you open the Pinterest or Netflix or ShareChat homepage, we don't know what you want. You're not explicitly telling us what the intent is. So these are the two like extreme views, right? In search, you're explicitly typing in a query, and that tells the platform what your intent is. Whereas on recommendations, most of the times you go to a homepage, and that homepage, you're not really typing in a query. You're not giving explicit signals of what do you want and what your intent is for this session, essentially. Now, this is interesting because now we can start mapping a bunch of different apps and a bunch of different surfaces in this space. That on the left extreme, we have the search wherein the intent is very explicit. On the right extreme, we have recommendation surfaces, mostly homepages, wherein there is zero evidence of intent at the moment when you start the app. But then in this spectrum, a bunch of things start happening as well. There are things in between. If you look at YouTube on your mobile devices, then there is a panel at the top of YouTube, which is a bit more intent guide. Here's the recommendations on the homepage. But then if you want something new, or if you watch some medical dramas or whatever, you're going to click on that, and then the homepage is going to structure itself. Similar to Spotify as well. Spotify has these explanations that this is new for you, or this is because it's Friday. So there is a bit more intent guidedness is starting to pop up in some of these homepages as well. And again, not all recommendation is intent agnostic. If we start looking at things like All Out 80s, so All Out 80s is a famous playlist on Spotify, and this is a bit more content specific, right? Because here the intent might be different, but at least the realm of the intent is defined. Because the realm of intent over here is all the music coming in from the 1980s, essentially, right? Now, within that, your intent might be that, hey, I want to discover. I have never heard 80s music. Let me just discover it. Or you're very used to 80s music. You just want to enjoy that, and you already have developed your taste preferences accordingly. So the point is, if you look at the spectrum, right, then on the leftmost extreme, we have more search and conversation-driven interfaces, wherein you're explicitly providing your intent. On the right side, we have recommendation surfaces, wherein like app homepages, wherein there is no intent. And then there are things in between where there is a tinge of intent, or there's a content relevance awareness, wherein All Out 80s or songs to sing in the car. So some of these surfaces on these different recommendation apps are more guided towards certain intents, like Discover Weekly as well, right? Discover Weekly is a playlist wherein you're going to discover content for sure. Or if you go to the Explore page on Instagram or ShareChat, you're going to explore a bunch of different category content. So these are not purely on the left or purely on the right. So we start seeing this mix pop up across different surfaces. Now, what does that mean for us? That means it's fun that the intent specificity, that the specific intent which the user has, the intent specificity varies across surfaces. So in search, it's more explicit. In Rexes, it's a bit more implicit. But then within Rexes, by Rexes, I mean recommendations. Within Rexes, different surfaces have different types of. So again, like if you look at All Out 80s, there's songs about 80s music, but also if you look at the FIFA World Cup tab of ShareChat, then you know that the user wants some content about the FIFA World Cup. But what in it, like the scores or the schedule or the upcoming matches or some memes, we don't know that. So the intent is not explicitly defined, but still is within a certain limited horizon. And then the problem is that it has huge implications on the recommendation models. Because if you look at let's say an All Out 80s or a FIFA World Cup tab, then there is an editorial input, right? Because what content has to power these All Out 80s versus one of World Cup tabs on a content recommendation app, they're guided by some editorial input, wherein the editors or human domain experts are bootstrapping the surface. So hey, I think these are good tracks for All Out 80s. I'm an editor, right? Let's say there's a Urdu poetry playlist on Spotify, right? ShareChat has a separate tab for poetry in Hindi. Now around that content, what is a good poetry? What are some good songs in this genre? There are domain experts who can start providing an initial list that, hey, you know what, maybe these are 100 good songs, but then we don't want to recommend like 10 million users from the same 100 items, right? So then the ML can start taking over. The ML model can step in and say that, hey, great, you're providing me with an initial bootstrap list. What I can do next is I can take over and then go from these 100 to a few thousands, and then start personalizing from that to the users. So there's a mix of editorial input and recommendations starting to come in, especially in gray areas wherein the intent is like not really explicit or not really implicit. And also the second point, which is very critical, that the tension between user personalization and content relevance starts to pop up. Because on search, right? On search, there's an explicit query and we have to be providing relevant content. On recommendation, it's more exploration, right? It's more like that we want to surface something to the user which they might enjoy. But then there's content relevance need not be matching to some very specific need because there's no query. But if you start looking at things in between, like the FIFA tab on ShareChat or the All Out 80s playlist on Spotify, this is where you want a nice balance between personalization and content relevance, because you don't want to show content which is not relevant, right? So the outer boundary is decided by content relevance. No music from the 1990s or 1950s or the early 2000s, they are not going to pop up in your All Out 80s. So there's a realm defined by the content relevance. Within that, you can personalize. So this is where like identifying where the surface is, how much you want to pay respect to user personalization versus content relevance is an important problem. And all of these have an implication on what kind of models you actually designed for the different surface. So taking a step back, right? What's the takeaway, at least so far? So far, we have looked at that there are different recommendation surfaces. Now, some of these apps are more explicit, some of these are less, some of these are in between. And if things are in between, then we will have to be mindful of the content relevance versus user personalization bit and then balance it accordingly as such. But then let's start with identifying the intent space itself, because as I mentioned, we're going to divide into three parts. One is, what are the intents? Two is, can I predict the intent? Three is, can I use this intent? So in the first part, we're just starting with mapping the intent space itself. Now, this is where like you'll have to treat the search and recommendation problems very differently. Why? Because in search, the user is explicitly providing you certain input, and recommendations, they're not. Most likely, they're not. So let's start with search. We're going to see the, and then we're going to maybe verbally mention what the relationship between the two could be. So if you just start with mapping of intents in search, then in search, like typically there is a search session, right? Each user comes in and they start querying certain things. And based on those queries, we can understand that what your goal is. But then essentially, if you look at your search histories, then you're going to be searching a lot. And for some of these tasks and intents you have, if you want to buy a house, right, then it's not just like one session. You're going to spend like months and months developing your understanding of what does it take to buy a house. You're going to do a lot of querying around different aspects. So most of the time in search, at least, once you have these queries, then the goal problem formulation itself is different. It says that, hey, I have a sequence of user queries, and it's like very interleaved, right? Sometimes the user just goes to Facebook. Sometimes the user just starts watching some cricket videos or something from YouTube. And other times the user comes back to the main goal. The main task was, let's say, buying a house. So there's a lot of interleaving going on here. And the way search systems would solve this problem is that we can look at the history of a user session or like across multiple sessions, look at the queries, and then try to identify what task the user had when they were issuing those queries. And there are many approaches of doing it over the last 10, 15 years. I'm just going to talk about three of them just to give a flavor of how, at least on search, when you have explicit inputs, then you can start identifying user tasks. So we're going to talk about three approaches. One is the structured SVMs. The other one is a bit more temporal using Hawk's process. And the third one is a bit more hierarchical. So before we go there, let's first look at the figure on the left. The figure on the left is there's a user, and over a period of, let's say, a couple of months, they've had multiple search sessions wherein they've issued multiple queries. And now my goal is, can I extract intents from this sequence of search queries? Now, one thing to highlight here is it's not just about this user issuing this set of queries. Now, very similarly, there are maybe 10,000 other users trying to buy a house right now. And then there are a million other users trying to do different tasks. So this is what your search log starts looking at. You have, let's say, 10 million users, and across each of these users, you have a few hundred queries, and that gives you like 100 million queries. And that's the log which I want to use to understand, hey, what do users typically do on my app? So this is the problem which you're going to tackle in the next 7 to 8 slides. We're going to look at a huge search log of queries given by different users across different amounts of time. And then we're going to try to identify, hey, what is it that people use my search engine for? What are the tasks people do? What are the intents they have when they come to my search system? So if we start with the first approach, which is structured modeling. So this is where there is a sequence of queries. Now, maybe the green circles are about certain tasks. The blue circles are about certain other tasks. There's a bit of interleaving going on in here. Now, the goal over here is that, can I use a structured prediction to solve this problem? Because here, the idea I want to convey is that there's a linking structure that the query Q6 is related to Q5. Q5 is not related to Q4, but it's related to Q3 instead. So there is some hidden links going on between queries. I don't know them. So can I use a structured prediction to solve this problem? So essentially, like the way there's a very nice paper I read a few years ago, which is using some sort of like latent structural modeling for structured prediction to understand these hidden links. And the goal over here is that if I can maximize the probabilities of these inter-query links, and here the goal would be that there's a space of task partition. If I have a series of queries, I can partition them into certain tasks, into certain intents. And then what I can do is I want to find the best link between these queries given a query relationship. So this is where the first step is, can I find the best link for each query? And then once I have that, then I can propagate that across all the other queries and then try to learn this hidden structure itself. So again, the goal over here is trying to learn the latent, because again, the user never explicitly tells me this query is related to the previous query. So the goal over here is that can we identify these links, and there is a way of solving it, because there is something called best link SVM, which is a structured prediction model using SVMs. This is like about 10, 12 years ago. There are solvers for these. There is at least like one neural reimplementation of structured prediction in the later neural modeling world. But the key idea is that if there is a hidden structure and I want to find that, then I can use some of these to extract these tasks and intents for me. There is this other aspect as well that, hey, there is a temporal aspect. Can we like consider that temporal aspect itself? So here is another example wherein people in search, right, they started to identify these temporal structures. They said that, hey, I mean, there is a bit more relationship here, that the queries are topically related, but also over a period of time, they're changing. And if a user has issued query from one intent, then there is a high chance that the user is going to continue that intent in the coming time. So the key problem here is that there's a lot of like topical similarity between search queries, and there's a temporal aspect. Can we combine the two together? So this is where the two problems start merging, that if the queries are topically coherent, then that they may be from the same task, same intent. If they're temporally close, maybe they're from the same task, right? Not necessarily. So this is where like you can start merging the two. Like for topical coherence, you can start looking at topic model style work. For temporal coherence, you can start looking at Hawk's process. So topic models are, again, like they're pretty old now, unsupervised ways of extracting topics. Hawk's process is an interesting topic. Basically, Hawk's process, what it says is that if there is an event which is triggered, then the next iteration of that event to trigger is temporally guided. So imagine like an earthquake, right? So the moment an earthquake happens, then the probability of aftershock is very high in the next 2-3 minutes. And then over a period of time, that probability of an aftershock keeps on decreasing. Same for stock market, right? If there's a huge sell-off, then it might just trigger a few sell-off events subsequently. So when we see that there's a lot of like real world interaction data, which has self-excitation property, that whenever something happens, the probability of that happening again or a related event happening again in the near future is very high, and then it decays over a period of time. So this is something which is captured pretty well from this Hawk's process style model. And these are point process models which have a background intensity that, hey, what's the probability of something like this happening? And an additional term, which is the correlation with the past event. That if something happened just 1 month or 1 minute ago, there's a high chance of that happening, but then over a period of time, the correlation with past events decreases. What's my point? My point is, independent of intents and tasks, right? There's a way in which you can model these temporal behaviors using Hawk's process. And now if I go back to the core problem, that a user, if I'm querying, let's say, how do I buy a house in Bangalore or in London, then I'm going to issue very similar queries in the next few minutes or in the next few sessions. But then after a month, maybe I'm going to change my search behavior, search queries. So this is where like people wanted to combine the two processes. That can I look at the task from a topical correlation and from a temporal correlation view, and then combine it together. So there's that series of work which has gone into deciding and identifying these user intents, which has a temporal aspect. Now, let me go into the third aspect here, which is it's not just about linking a flat structure, right? Because most of my times, the intents are not just one intent, right? There could be a hierarchy of intent. If I'm planning a trip, then I might need information about the visa. I might need information about the flight booking, about accommodation, about places of interest, about travel, local accommodation, local travel, all of these, right? So if we start looking at it, then so far we've just looked at intents and tasks from a very flat view. But then often there is a hierarchy, and then we need models which can represent this hierarchy itself. Now, binary trees and those are like very limited, because a binary tree just says that, hey, one task can only have 2 subtasks. So then we need models which are able to represent this hierarchy with like arbitrary number of branches, essentially. Taking a step back, before we go into the hierarchy model, where are we? We've said that, hey, we want to identify intents, and especially in search, we'll get to recommendations in a bit, especially in search, when we have users issuing certain queries or providing some explicit data, then I can start looking at that sequence and then identify, hey, what is it that the user is trying to do? What is the user's intent here? And we've looked at a couple of models that maybe they're doing a few things in between and they're like temporally interleaved. So maybe I can look at structured SVM, structured prediction problem, or a temporal process problem. Or maybe I can do a bit more modeling, which is model them into a hierarchical intent space. So what we're going to do next is look at one way of constructing this hierarchical intent space. So there's something called like Bayesian rose trees. So essentially what you can do is you can start treating this problem from a Bayesian non-parametric view. And a Bayesian non-parametric view says that I can assume that there's a latent hierarchy, which is a Bayesian rose tree. Rose tree is just like each node can have arbitrary number of children. And essentially, if I have that structure of my tree that each node can have any number of children and so on, then I can start representing my logs as a set of arbitrary partitions recursively. Now let's see what that means. If you look at the tree on the left, right, then the overall, right, start seeing that the node, I have 4 children. One is a subtree, which is ABC, and then D, E, and F are separate. But then when we zoom in onto this, recursively zoom in on the first partition, ABC, then I can see that, oh, here I have 3 children. At the root, I had 4. At the first node, I have 3. And then I can go into, okay, this is A, B, and C separately. So if I start doing it recursively, then I can create some of these hierarchical partitions. Now, the goal over here is that we don't know what this hierarchy is. We just have evidence of search logs. Right? So this is a problem we're trying to solve here, that given a huge collection of search logs, can I recover this hierarchical partition space? And this is exactly where the way we formulated this problem was that, can I find a tree structure which maximizes its probability? So this is like a mixture over partitions of data points. So what is this probabilistic distribution over all these hierarchies, which is going to maximize the likelihood of observing this query log? And this is where the number of partitions, because again, it can be done exponentially large, right? Because each node can have 1, 2, 3 arbitrary number of children. So then there's a bit of approximation which we did using dynamic programming. And here, if you look at this equation, we're trying to say that, hey, the probability of observing this query log, given this tree structure, it's a combination of the probability of queries belonging to the same task in this node, plus some factor of this node getting recursively distributed in its subtrees itself. Now, this is where the hierarchical structure plays out. At the top, I'm going to say, okay, what's the probability of me getting this query log given this tree structure? Okay. Then, which is at the node, what's the probability of observing all these queries belonging to the same intent? That plus the probabilities of my children, right? That if I divide this node into subsequent nodes, and what's recursively, if I can put the same equation again, that okay, for each of the subtrees, can I follow the same probabilistic approach itself? So this is a recursive way of identifying what a nice tree structure here could explain the search log. And that tree structure would give you the intent partitioning of the space. Quick summary, where are we? We said that in search, when you have explicit data, then people can start looking at some of these models to either develop some clustering. The simplest thing is just clustering. You cluster queries into groups and they'll give you some intents. Or you can do some structured prediction, temporal awareness, or like a hierarchical extraction. Now, before we go into recommendations, right? Now, oftentimes, let's say if you're using Pinterest. So Pinterest is more of a recommendation product, but also it has search bits, because search behavior is guiding. If I'm doing a redecoration of my house, then I'm going to start searching some of these related pins. Or if I'm on YouTube, then maybe like on a weekend, I want to watch some nice documentaries. And also maybe I'm learning of a different language, let's say French. So then I'll keep going to YouTube for a bunch of like French videos. Or if I'm learning about stable diffusion, I'm going to keep watching some of those tutorials about any topic, right? So the problem we are identifying in search, the solutions, right? It's not just applicable to Google and Bing and just pure search systems, but also in a lot of recommendation products as well. This is where the intersection starts happening. Because on Twitter, on Twitter, you might just always go back to a certain tag, or you might have a nice probability that, hey, I'm going to look at what is going on in Rexes. So I'm going to go back to hashtag Rexes 2022. So essentially, the point I'm trying to convey is that the methods we have seen so far, while they were developed mostly for search engines, but then they're starting to being consumed and used in a lot of like recommendation surfaces, which are more similar to search than just pure homepage. So we looked at some of these intent understanding modules from a search perspective. Let's dive into a bit more recommendations. Now, in the recommendation problem, like at least when you go to the homepage of ShareChat or Netflix or Spotify or Pinterest, you don't provide any query, right? So there's a 0 queries issued by the user. So there's no explicit signal given by the user yet. And then the space of intents is also unknown. Not just for this user, but also, how do people use like ShareChat? How do people use Spotify? What are the intents there? What do users do with it? What are their needs? So in recommendation surfaces, it's a very hard problem to identify these intents. Why? Because there's no explicit query in most of these surfaces. On the app, you'll have some search behavior, which is going to be like maybe driven by 2 to 5% of your users at the start. But then on most of these homepages, you don't know what the intent is, right? Which makes it a bit more challenging to identify your intents. So this is where, if we start looking at the intent space identification, then there's a few different approaches of doing it here. We're going to talk about two of them. One is a mixed method approach, and the other one is just latent approach. So in the mixed method approach, there's some work from Spotify and Pinterest. We're going to talk about each of them. They're very related to each other. And then we're going to go into an ML latent view of intents. Now, this is where we don't have any query. User goes to homepage of ShareChat or Spotify or Netflix. There is zero query issued. None of the users have explicitly told us why they want to use the homepage for different intents. So what can we do? So the goal here, if you start focusing on the first, how Spotify tried to tackle this problem, we had a mixed method approach wherein we were doing a bunch of user interviews, user research, doing some in-app surveys, and then some large-scale quantitative backing of the insights. So first, we started with user research that we conducted some in-person interviews. We brought in like 15, 20 people from different age groups, gender, demographics, different like professional dimensions. And then we asked them questions about the music habits, the usage of the app, their current experience, and whether they want to discover music or not. And also, like, we recorded the sessions. So imagine you come in as a user, you're using the app in front of us, it's getting recorded, audio interaction data, kind of visually recording it. And then we're asking you a bit of questions like, okay, how do you use the app? What kind of expectations do you have? How do you use this playlist? Do you discover content? Do you create some of these playlists for sharing with your friends? What are the goals essentially? So just doing some of these in-person interviews started giving us a sense of, hey, these are a possible list of what users use the Spotify homepage for. So again, it's not definitive, but it's starting to give you an initial sense of what does that intent space starts looking like. This is when you can start doing an in-app survey. So imagine when you do some user research, you compile the findings, present that, hey, I think there's an initial list of 19, 20 intents emerging. Now let's back it up with large-scale data. So this is where you can start doing some in-app survey. In-app survey, what we did was on the homepage, we started showing a mini pop-up that kind of popped up, and then just a couple of questions that, hey, how happy are you with the current session, and what were you trying to do? And what we're trying to do, we don't want to type in give a box because nobody's going to type that. So then if we can use the initial intent space from the user research and then start showing some options to the user, then we can start collecting this large-scale data. So if you release it to, let's say, a few million users, we got a 4.5% response rate. 2 to 5% is typically the range of these responses. Again, this is going to differ, right? Some people are just going to email the survey, and emails will have very different response rate, and in a pop-up will have a different response rate. And the problem here is that if your survey pop-up happens at a bad timing, then you're disrupting the session, right? And then the user satisfaction will go down, and there's a lot of like problems in interpreting this data. So what we ended up doing was we ended up triggering the event when the user was going from the home tab to the search or a playlist tab. So again, like, it took us a lot of back and forth and iterations to find out when do we actually trigger. A bunch of these details are in the developer paper, which is mentioned in the reference here. And then once we do that, then we start collecting this large-scale user data. Now, then we'll get a distribution. Okay, what are the users telling us? The users can also tell you some other intents, right, which you didn't have before. And then we had to do some sort of like non-parametric clustering to find out, hey, there's a new intent popping up, which we didn't get from user research, and then we can start combining it all together. And then you can do some large-scale qualitative data backing, right? Because for each of the users who have given an in-app survey response, maybe it's like close to 500,000 users. And if they give you a survey response, and for each of these 500,000 users, you have the logged interaction data. You know that on Monday evening at 6:30 p.m., they filled the survey. So let's look at the 1 hour before that time. And then you go back and look at your interaction logs. You'll get for this user, what were they doing? And then you can match it with the label we have for the user, right? That if the user said, I'm doing this intent, and then you start matching that, okay, what sort of behavior correlates with what sort of intent? So that's where, like, we did a lot of like large scale data analysis to match the in-app server result with the user, with the server responses essentially. And then we were able to identify like some hierarchy, I mean, at least two level of intents, passive versus active. And actively engaging, it's more about discovering content or saving new music for later, exploring different artists or albums. In passive, it's just wanting some quick access or just some music to play in the background or music that matches their mood or activity. So again, we were able to identify a few different types of intents. Again, this is not an exclusive, exhaustive list, right? But then like we conveniently ignored the long tail here because the bulk of these intents capture like most of the consumption habits on the homepage essentially. Now, very similar is what like Pinterest did, right? Again, there's a very nice paper from Pinterest talking about intent understanding. And there, the point which is raised was that, again, intent precedes any behavior. So again, we observe user behavior to understand intent. So there they started by looking at organizing the queries and like the kind of pins people were clicking. And based on that, you can start identifying this question that, should my intent space be more experience related or more goal related? And if you start looking at goal related, then I'm searching for a car image or I want like a wedding bouquet. So again, based on the pins users are interacting with, they could be either goal or experiential. You can also start looking at combining this with the large scale survey. And in the survey, right, similar to what we did at Spotify, in-app survey, Pinterest followed a similar approach. Then there were two dimensions of that, which is like goal specificity and temporal range. One example is that if you start looking at different intents on Pinterest, then the less specific is I just want to kill some time. More specific is I want some cake recipes. Something in between is like gardening ideas. So here you start seeing that if I have the user engagement or user interaction data, I can start looking at dividing this interaction data into different types of intents along different dimensions. It could be specificity or like temporal range as well. So short term could be that, hey, I just need a recipe for dinner tonight. Long term is like, okay, I mean, I want to plan a wedding, and then what does it take? Or I want to redecorate my house. Can I start compiling pins in that realm essentially? And then you can start mapping different behaviors on these dimensions, right? That some of these are less versus more specific, some of these are short term versus long term, and then you start mapping out your intent space essentially here. And then again, like the large scale survey will just back up. You can, very similar to what we did at Spotify, you can replicate that and say that, okay, does the survey data match the inputs which users provide? And also not just the survey responses, right? But you have the behavioral data along with it, and then you can match the two together and see if it's like working out well. So taking a step back, right? Where are we? You said that in search, we have queries and I can do some temporal modeling, hierarchical modeling, get some intents. In recommendation homepages, I don't know the intents. So let me do some mixed method approach. Let me do some interviews, maybe start listing down a list of few intents, but then I don't trust them because they've just come in from 20 users. So what I can do is like I can start launching some in-app surveys, maybe a few million or a few 100,000 users start giving you responses, you tie them together, back it up with your qualitative and quantitative data from logged interaction of these 500,000 users, and then you start looking at the intent space. So there is that's a mixed method approach, right? You're doing a mixed method of user research plus surveys plus qualitative and quantitative large scale data, right? So that's a mixed method approach. The other approach is like latent intents that, hey, I don't want to know what the intents are. At Spotify, right, we have this list that here is a list of 9, this is 6, but then here's a list of 9 intents on the Spotify homepage, and I'll start using it. But what if I say that I don't need that, I don't need to know what these 9 are. Give me the latent hidden ones. They could just be intent 1, intent 2, intent 3. I don't need to understand what these are. I just want to have them. So this is the latent intents are popping up. That if I don't need to have a human understanding way of what these intents are, I can just do unsupervised latent space mapping. Now, there's a very nice paper very recent, like 3 months ago from Google around learning user intent modeling for sequential recommendations. This is wherein like they started using the variational autoencoders for latent intents. And again, like the overall is a probabilistic graphical model approach. And what the overall point is that I want to model this in a graphical model and say that I know the past data of the user, which is X, which is observed. I don't know the user intent, which is hidden. So latent means hidden. In a probabilistic graphical sense, like latent variable means it's a hidden variable. I don't observe this at all. But then I know that the latent user intent is carried by the past behavior, and the future behavior is governed by the user intent, right? So essentially, you start doing this relationship wherein the first node X gives you the past behavior of user, which is observed. The node Z gives you the latent hidden intent, which you don't know, and your node Y gives you the future behavior. So what kind of searches, what kind of interactions are you going to do? Are you going to skip a video, watch a video, this video of this topic from this creator, all of that. So with this setup, right, a proposed approach was that, can I do autoencoder-based reconstruction loss-based model here? So I know that I have the X and Y, right? Because for each user, I know the past data, I know what they're going to do, and then I don't know what the Z is. So then maybe I can do a reconstruction. So I can encode the data, try to understand what my hidden state Z could be. And then based on that, I can just reconstruct what Y comes in future. And then based on that, I can get some hidden representation, which could be my latent intents essentially. So this is where, there are a few ways of doing it. One way could just be, again, the very simplest latent space could just be that, hey, there are these clusters. I don't know. I just look at user behavior data. I have some metadata about the content. I can do some clustering, and then each cluster is an intent, right? I don't know what that cluster stands for, but then it's an intent cluster for me. Or I can say that, hey, I don't even need to do clusters. I just need a 20-dimensional vector. Each of these 20-dimensional might be an intent. I just want a probabilistic distribution on top of it. And then I can get these 20-dimensional vectors from an autoencoder-based model or some other latent vector representation approach as well. So this is where a few ways of identifying intents, just mapping the intent space, right? So what have we looked at so far? In search, it's simpler, not easier, but with the search queries, we can do some modeling, get the intents. In recommendation surface, I can do two things, right? Maybe identify a list of 10, 15 intents, back it up with mixed methods, or say that, hey, I don't need to know them explicitly. I can maybe do a bit more of latent variable modeling. Now, these are the intents, but then with these, what do I do? Once I have these intents, then the part 2 kicks in. Then once you've mapped the intent space, now you want to start using them, right? To use them, two things have to happen. One is I cannot just use users' past intent, because in the current session, I don't know, like maybe the past intent is not predictive of future. So in the current intent, I want to understand and predict what the intent is going to be as quickly as possible. And the way to do that would be a simple intent prediction model, right? The simplest approach is pretty simple, that you have already the data from in-app surveys. So you can match the in-app survey response with the logged interaction data. So imagine like the 500,000 users who responded to the in-app survey, which we did 3-4 years ago. Now for each of those, right? And we know that the user is saying that this was my intent when they click the survey response. I can look back from that time, half an hour before, in the last 1 hour, last half an hour, what were the interaction signals? I can extract features from that. The label is already the user response, and then I can develop a model. So this is where I can start looking at any sort of interaction signals I have on the app. So it could be the session length, the time played, the dwell time on a homepage, the number of songs played. Are you scrolling more? Are you going back and forth a bit more? What's the max depth, number of exits, abandonment, intentional, a bunch of different features, right? So imagine like having 50, 100 plus implicit interaction signals on the app, which you've logged, right? And you've logged and extracted these features. You already have some, not huge, not 100 million users, but maybe 500,000 users data for what they said the intent was, because that's the explicit data you have. Then you can start training some of these models. So again, that's the simplest approach, to look at interaction data, look at some ground truth label, and then start predicting intent. Now, a key question which the Pinterest paper answered was like, how quickly can we start predicting this intent? So then they found that maybe after 10 minutes, we are able to sufficiently predict intent with some good AUC scores, right? Again, why? Because after 10 minutes, maybe the performance is like not increasing too much. So 10 minutes is sufficient. But then they figured out that intents can be predicted much more quickly, right? At 30 seconds is a pretty decent AUC, and there's a drop. If you look at the 10 minutes versus 30 seconds, there is a decent drop, but it's not as bad. So intents can be predicted like much more quickly. But the best part was the intent can be predicted even before the session begins. Again, of course, it has the lower AUC than maybe when you're at like 30 seconds or when you're at 10 minutes. But then past user interaction data, past behavior is predictive of some of these intents in the future, right? So this is where you start seeing that, hey, if I have to start using this to do something, right, which you're going to get to, how do we leverage it? Then this is the way. At the start, I don't know what the intent space is. Let me start mapping it out, either using latent variables or using some explicit intent space modeling I do. Once I do that, then the moment a user comes in, imagine like you have this intent space of maybe 15 intents, and I want a distribution on top of it. That, hey, I think the user has a in this session, the user has an intent of like intent 2 with probability 0.5 or 0.7. Now to do that, I can do a time is equal to 0 prediction. That at time 0, this is what I think the user's intent is going to be. But then the moment I observe more, at 30 seconds, I have some interaction data. I can do some in-session understanding and then update my prediction, intent prediction. And then after 10 minutes or so, I already know because I've observed a lot of data. I know what the user is going to do on my app. So this is how you start predicting intents. And once you do the prediction, then the goal is to start using them, right? Which is the third part. That how do we start leveraging these intents for some downstream task? Let's take a step back before we go into the next section for 5 more minutes, and then we'll wrap up with some discussion. So what we've done is we've said that, look, again, if you've been hopefully not sleeping, but then maybe somebody in the US is like way too early, if you've been kind enough to join in a Sunday early morning session, this is your ramp up back to what's going on, what we've been talking about for the last 40 minutes. We've said that intents are great because they tell us what users want, right? I can use intents to do some personalization. But then there's a problem. Like in search, people type in a query. In recommendations, they never type in a query on the homepage. How do I do that? So in search, we looked at some approaches of you have a query sequence, interleaved with the intents. There's a few ways of extracting it. Maybe some temporally, maybe some structured prediction, maybe some hierarchy. Great. In recommendations, I don't know that. So on the homepage, if I don't know, then I can do two things. One is just give it up that, hey, I don't want to understand intents. I just want to have some latent intents. So then there's a latent variable modeling way of doing it. Or I can explicitly define my intent space, do some mixed method approach, do some user research, in-app survey, back end a bit qualitative, quantitative insights, and then identify these are the set of 15, 20 intents we have. So that's part one. Now with that, what do I do with it, right? Great, I have these intent space mapped, but then with the intent space, now I want to start predicting. User comes to my app. I'm like, okay, these are my intent space. I don't know what the user is going to do. Let me make a prediction at time 0. Great, I do some prediction. But then the user starts engaging and I can define my prediction. So over a period of 30 seconds, 1 minute, 5 minutes, 10 minutes, I have a pretty good idea about what the intent users have. This is what leads to the last part here, which is leveraging intent. So how do we start using intents for better personalization? So again, I'm not going to go into exact details because of just 5 minutes actually remaining in the entire hour. But then just going to give you some flavors, some recent papers in the last couple of years of how people started to use intent. So again, this paper from YouTube is talking about using the latent intents itself. So here the goal is that, remember the variational autoencoder model wherein we had the Z latent vector, I can start using it and use it internally in an output like a user representation out of it. So imagine, right, there's an entire recommendation system, but now what you're doing is I'm doing some intent prediction, predicting that Z, and then using that internally in my core recommendation system. So this is like a way in which, just one example of using the intent as an internal intermediate representation, concatenating with other signals you have, and then providing a representation, latent embedding to your core recommendation model. The other could be a bit more explicit, right? And there's a paper from WWW last year, where again, if you look at on the left, right, there is an intent space, the pink and the orange and the blue, and then there's a distribution, and that distribution goes inside the neural model which you have for prediction or for re-ranking content. So this is where like you start using that for sequential recommendation, that I look at the user history, make some predictions, use that prediction in my neural network for sequential recommendation. But again, it's not just sequential, right? It could be multi-level reasoning as well. So there we know that, okay, how about combining it too? I mean, we've talked about hierarchical task, hierarchical intents, and we talked about sequential. Let's combine the two together. So there's a nice paper at Wisdom, I think Wisdom this year, 2023. I'm just going to correct that here, sorry. Yeah, so this paper says that, hey, you know what, there is a hierarchy of intents. So then maybe I start mapping this multi-level view of intent and then start using that for my downstream sequential recommendation task. And finally, some work we did a few years ago, wherein not just for recommendation, I can start using intent for evaluation as well. That I can have a global model. Let me give some background here. So what we did in this paper was that we started using intent for evaluation. So we said that, hey, we want to understand whether the user is happy with my user had a good session or not. Now to understand whether the user has a good session, let's find out what the intent was. Because if you don't know the intent, how do we understand whether the user kind of fulfilled that intent? So there we started looking at some interaction between the interaction signals and the intent as well. So one example, which again motivated the bulk of this work, was if you're skipping a lot of tracks, right? So skipping, usually, if you're on YouTube, if you're on ShareChat, you're skipping a lot of videos, that's bad, right? Because say you want to watch a video, you're skipping it a lot. Same on Spotify, if you're skipping a lot of like music tracks, then maybe you're not happy, you're not finding the song you want to listen to. But then if your goal is to create a playlist for a function at your home later tonight, or you're throwing a party to your friends tonight, and then there skipping is okay, right? Because you're sampling songs, kind of saying that, okay, I listened for 10, 15 seconds, I added to the playlist, and it's a good session. I've done like hundreds of skips, but then I got what I wanted. The point over here is that if you want to understand whether the user is happy or not, then you can have a model which is global model, which is like intent agnostic. That here across all sessions, I have the same model. It has no information about intents, and then I can use it for understanding satisfaction. Two, I can have a per intent model that, hey, for each intent, because I predicted the intent, I can do a satisfaction estimation for each intent separately. But then there, the problem is you don't have enough data for each of your intents, so then it goes into sparsity issues. What I can do then is, I can combine the two. I can have a multi-level model. That there is a set of parameters which I use across all intents, but then there is certain parameters which are intent specific. And then a combination of that gives me the satisfaction. What's my point? The point is, when you're using intents, you can use intents for not just giving you some embeddings you can use, not just for making sequential recommendation or multi-level sequential recommendation, but also for evaluation. That once you have the intents, you can do a better job at evaluating different models in offline evaluation and A/B testing, and make better decisions in production. So that's where we are. The overall summary is the intent understanding across different apps needs a different thinking. On search, you have queries, you have to do different modeling. In recommendations, you don't have queries, you have to do some mixed methods or latent, or you have things in between. Wherein on Twitter, right? On Twitter, on ShareChat, you have these tags, and each tag is not a query, but then the user is saying that, hey, I need an information about this. So this is not really in search, not really in recommendation, but somewhere in between. And you can use different approaches to either map out the intent space or keep it hidden, latent, do some intent prediction. And once you have that, you can start using it for either in-session personalization, sequential recommendations, or for evaluation itself. So that's it. That's the summary. And so again, like the background here is that we do cover intents in the Core Eyes course, which we do on recommendations, but then haven't gone into as great a detail because that course is entirely about the multi-stage recommendation pipeline and how do you design a end-to-end recommendation system going from a big corpus to candidate generator to some ranker models to some multitask modeling. Part of that is intents. We've talked about that in the course. And then there was a few suggestions on, hey, can we focus a bit more on intents? So we thought we were going to come back and do a session on just intents in search and recommendation services. So yeah, that's it. We have a few minutes for questions and discussions. I see there's a question.
A question in the Q&A and a question in the chat.
Perfect, yeah. I'm going to go to the chat question first. What are some good approaches to recommend to categorize your queries data? Any suggestions on existing Python libraries? Yeah, I think one of the things which, especially in the intent modeling space, right, we often don't know how many clusters to use. And this is where, like, during my previous work, I used something called DDCRP, which is a Chinese restaurant distance dependent Chinese restaurant process. So again, it's a Bayesian non-parametric way. So Bayesian non-parametric way is important because in a task, right? I mean, in a hierarchy, I don't know how many subtasks will there be, right? So often when I don't know how many clusters do I want, so then we need some non-parametric way of doing it. And Chinese restaurant process is a non-parametric process, which can adjust with the data you have. And I think there's a Python library for DCRP. There's a C+ implementation, which is quite faster. I'm just going to find that link. David Blee has a nice library, which is, yeah, I think this is one of the libraries. Again, this is not the one which I based my implementation on. But yeah, so David Blee's website has a, okay, sorry, I got the surname wrong. Yeah, David Blee's website has the implementation of DCRP. There's a couple of questions on the Q&A. The intents gathered from user interviews serve as a basis. How do we pick new and maybe widespread intents that didn't come up? Great question. I think this is exactly like in the paper, we dealt with this problem that maybe users are not telling, again, like the user research might have easily conveniently missed some of these intents. And the way we tackled that was, just give me a second. I'm just gonna open the, oh crap. I'm gonna open the corresponding section from the paper. To control F. Yeah, so essentially, I mean, what we did was we said that, hey, do you have any one of these intents? If not, then there's an other section, right? So in the other section, people typed in a response. But then what we could do is like, you could do some clustering there. And because again, users are typing in, and maybe a lot of users are typing in certain intent, which we might have missed. But then a simple clustering may not work there. So that's where we use like a distance dependent CRP. We said that, hey, I don't know if you have a figure for this or not. We don't have a figure, but yeah, in this section of the paper, we have exactly tackled this problem, that close to less than 100,000 users, close to 70,000 users or something, they filled in the other, that I have something else, some other intent. And then we did some non-parametric clustering to identify, hey, are these some new intents merging up from the user responses by users typing in? And then we were either able to map it back to one of the existing intents, or we actually did create a couple of new intents from the user textual response itself. Yeah, so if users are typing in a query, then you can typing in a response to your in-app survey that, hey, I don't have any of these intents, I have another intent, and you can do some analysis on that text and then come up with a couple of other intents, which we actually ended up doing as well. Hey, Grish. Hi. There is a question from Grish. If a sizable portion of users perform search, should we always start with search logs for intents? Would it be fair to expect that successful user search intent should lead to dropping percentage of users seeking out search? Yeah, this is a very good question. Very good point. So again, I don't think like I have a scientific way of saying this, but then often user search means that users not happy with the code. Again, you go to the homepage, you don't find what you're looking for, you go to your search and then start typing, right? Again, that's at least I personally view it as a form of dissatisfaction, that users not happy, so then they search something. But then the problem here is the visibility bias, right? So just because a user is searching for a certain thing does not mean that's the entire intent space. And most likely, if only 5% of users are searching, that doesn't mean that all the 95% users also have the same intents and they're happy, right? So search will most likely will not have a lot of queries which are already successful on your app, right? So then those intents are already satisfied by your own recommendation models, and maybe they don't start popping up in the search history. Again, please take everything I say with huge grains of salt, because yeah, like just because a user is successful doesn't mean that other users are not searching. So I think like the overlap between, it's an interesting, I think we should also do that. That once I have some of these intents from the mixed method approach, and then the search intent, what's the overlap? I don't think like I'm aware of work which has looked at search and this intent in a combined lens. The second point is also nice, that would it be fair to expect that successful users of search intent should lead to a percentage dropping in users seeking out search? Now, this is a nuanced answer is like, this need not be true, because I think like over a period of time, users' expectations from the platform also evolves. So right now, right, I may not be searching for certain things, right? I don't know that, hey, oh, there are like amazing astronomy videos on ShareChat. Great, I never knew that. Then the next time when I enrich my understanding of the platform and what it offers to me, then I'm going to start querying that as well. So I think over a period of time, as users become pro users, their behavior dynamics changes, their expectations from the platform changes, and then they start seeing, I now know that on YouTube, there's a bunch of videos around this topic. I never knew that I could find this content as well. Same on the short video apps as well. So my search habits are also guided by my kind of increase in the perception of what the platform can provide to me. And also there's a learning curve, right? And 4 years ago, when I asked Google Home some of these questions, it was stupid, it didn't answer it. But then the teams behind Google Home added a bunch of these tasks, and then now I'm able to ask some complex questions. So there's a bit of learning and forgetting involved as well. I mean, if I search for a topic today and the system does a bad job, then I know the system is not able to tackle it. But then and then I'm not going to query. For this topic, I've already formed a perception that the system is not doing a good job. For the next 2 weeks and next 2 months, I'm not going to query this again. You lost me as a user on that information need. But then maybe like I start seeing some of that content on the app and start searching again 3 months down the line. And if you're able to then solve that problem for me, then I build that trust back in the platform. So there's a bit of like user trust and perception going on with search and search usage on the app, essentially. There's a question from Aruchian. When you're doing any kind of intent analysis, how do you account for bias from the product? The order of songs may affect what the user does. Yeah, that's a good point. So there's a bunch of bias when we're doing intent understanding. And one of the biases, which we actually mentioned in the paper, was a bias of interrupting as well, right? If you show a pop-up when I'm just starting to form an intent that, okay, this is what I want to do. I start with an exploratory intent that I just have 10 minutes. I just want to waste 10 minutes on one of these apps. But then like I was in the way of finding what do I really want to find out and consume, then there's a pop-up, right? So then I may not have formed an opinion by then. So then it's a disruption, which we should try to avoid. But then in terms of the ordering, I think the goal, if you really look at it, the abstraction of the intent space defines how much leeway do you have with respect to some of this ordering. I'll give you an example. At the highest level of intent space, right? Imagine there's an intent space, right? And then at the highest level, there are like some very high level abstractions. The more you start going down, then you start zooming in. It's not just cricket, it's like watching a score. It's not just watching a score, it's like watching yesterday's match score or watching the schedule. So as and when you dive deeper into the intent space itself, there the need for such position level or like item by item accounting plays out, right? If I start zooming, if I focus on a per item basis, then I know what exact granular intent the user had, and then I can do that mapping. But then if I zoom out, if I look at one item, that's very granular. If I zoom out for a 5 minutes session, 5 minutes on share chat would mean maybe 10 short videos, right? Now 10 short videos, maybe there is a theme over here. Now that theme may be like one level generic, that hey, it's more like cricket schedules, not like a specific schedule, but like maybe some sports schedule. And if I zoom back again, 15 minutes would be like 30, 40 videos. Now that might again go back one level higher in the intent hierarchy space. So I think, yes, the order and all would play out a role, but also that's really depends on, do you want to do that rich modeling? And I think like you want to do that richer modeling once you're able to identify the intents at that granularity. And if you're not doing that, then maybe it's okay for us to zoom out a bit, look at the set. Instead of a sequence, I can look at the set together and then do some intent mapping essentially. This question, what would be a straightforward way to evaluate any personalization system? Yeah, I think like evaluation is a beast of a problem in itself. There's a very nice tutorial from my ex-manager, Munia, on user engagement tutorial system. Yeah, so this is like an amazing, I'm just gonna provide that as a link in the chat. We also cover evaluation in the course, by the way. There's a week in which we focus on evaluation metrics itself. It's not loading in. There's a very nice tutorial. There's a website as well. Yeah, okay, yeah, perfect. There's a website. Yeah, so there's a website which kind of provides a tutorial on like how do we look at user engagement and evaluation. There's again, one of my ex-managers at Spotify, Fernando. There's a very nice tutorial at Newrips on evaluation. I don't know if I'm able to find tutorials here. Yeah, perfect. Yeah, okay. So this is another amazing tutorial on mixed methods approaches of developing evaluation. So these are two like amazing tutorials, part of it which we cover in the Core-Rise recommendation course as well, which are great to look at for evaluation purposes. This question from Matthias on what lift can we expect after implementing of intents? Great question. So there's a question on what lift can, again, it's an excellent question, right? Like, hey, I'm doing all of this. Is it even worth it? So I would suggest that if you look at this paper, hopefully in a few months down the line, I'll have a share chat paper to quote for this. If you look at this paper, latent user intent modeling for sequential recommendations, it has results from live A/B test, and they provide like a 0.12% overall metric. Again, like 0.12 for a very mature app might mean the world, 0.12 on a slightly newish app might just be noise, right? So I think, yeah, 0.12 at a YouTube scale is what was quoted in this paper. So Yeah, share chat, not intent modeling exactly, but like in-session understanding has given us like pretty significant D1 retention gains over the last year as well. Will it be possible to? Yeah, we'll share the presentations definitely. There's another question on like measuring recommendation accuracy or success. The link tutorials is a good way to look at it. And I mean, those tutorials have a bunch of very good references. And yeah, we do also cover evaluation. Evaluation is not just like offline evaluation, right? It's not just like one metric or a few metrics. It's also like offline, online correlation. That if I have let's say if I use NDCG for my offline evaluation, but then is it predictive of online metrics as well? That's a big problem, because if I use a metric A and metric A tells me that, hey, you have these 3 rankers, ranker A is going to really perform better than ranker B. You do an A/B test in production. Turns out ranker B is performing better than ranker A. Then you don't trust your metric A at all. Why? Because metric A has very little offline-online correlation. So this is where like it's not just about metrics and evaluation metric, but also like offline-online correlation. And then do you really trust your metric? Is it even sensitive? Or is it giving you directionally correct? So for metric, it could be 2 things. One is it's telling you B is better than 1. So that's could be directionally correct or directionally incorrect. That, hey, A was better than B, then it's not directionally correct. Maybe it's directionally correct that, yes, B is better than 1. And then comes in the sensitivity of the metric, that your metric is saying that, hey, B is better than 1, B is better than A by 3.9%. You test it out, in the actual A/B test in production, it turns out B is better than A, but only by 0.2%. So then you're not sensitive. So there's a lot of nuances around sensitivity and offline-online correlation on the evaluation. And yeah, offline-online correlation is a very nice tutorial as well. It's a very important industrial topic. And to the extent that like in our recommendation course, we're dedicating a week. There's a couple of projects on like counterfactual evaluations as well, wherein in the course we paid attention to, can we do some offline-online correlation, or can we do some counterfactual evaluation, IPS, inverse propensity weighing style approaches for evaluation as well. So again, a bunch of like very interesting topics in the evaluation I mentioned.
Okay, awesome. Thank you for this, Rishabh. If you are interested in learning more about this, Rishabh's Personalized Recommendations at Scale course on CoreRise starts next Monday. So definitely grab your seat now if you're interested. And with that, thank you so much, Rishabh. And we'll see everyone hopefully soon. Bye, everyone.
Thanks everyone for this. Have a good week.